Energy. It's a word we throw around all the time, but what is it really? Well, it's the force that powers literally everything, our bodies, our homes, our whole world. It is everywhere, and it's in everything. So, let's dive in and really unpack what's going on.
Okay, to get us started, just take a look at this picture of a bus going up a hill. How many different kinds of energy do you think are happening here? Go on, just take a wild guess. We're going to come back to this at the very end, and I promise you'll see it in a completely new way.
So to solve that little puzzle, we have to start with the basics. First things first, what do scientists even mean when they use the word energy? You see, in its simplest form, energy isn't really a thing you can hold in your hand. It's more of a capability. It's the power to do something, to make something happen. And the most important part to remember is this. For anything at all to change, to move, to get hot, to light up, energy has to be moved around or changed from one form to another.
And this is the golden rule. It's one of the most fundamental laws in all of physics, so you got to remember it. You can't just make energy out of thin air, and you can't make it vanish either. It just gets stored, moves around, and changes its form. Think of it less like something you use up and more like a cosmic currency that's just constantly being exchanged.
Okay, so now that we have a feel for what energy is, how do we measure it? I mean, how much energy does it take to run a race, or even just to climb a flight of stairs? Well, let's see how scientists actually put a number on it.
The standard unit for measuring energy is called the joule. But here's the thing. A single joule is a teeny tiny amount of energy. So we usually talk about thousands or even millions of them. But what does that actually feel like in the real world?
Well, think about this. That feeling of effort you get when you walk up the stairs from one floor to the next, that's your body using about 2,000 joules of energy to make it happen. And if you decide to pick up the pace and go for a run, you're burning through about 200 joules for every single meter you cover. You can see how that would add up really, really fast on a long run.
But now, compare that to this. Just to boil a liter of water for some tea, that takes a whopping 400,000 joules. That really puts into perspective the massive scale of energy needed for different jobs.
All right, so we know energy gets moved around, but it also has to be stored somewhere before it can get used. You can think of these as different kinds of energy accounts. Let's go through the main types. First up, we've got kinetic energy. Now, this one's the easy one to remember. It's just the energy of movement. Anything that's moving has kinetic energy. It doesn't matter if it's a huge planet orbiting the sun or this cheetah sprinting across the plains. And the faster it goes and the heavier it is, the more kinetic energy it has. Simple as that. Next up is gravitational potential energy. This is basically stored up energy an object has just because of how high up it is. Take these skydivers, for example. Way up there, they are just packed with potential energy. The moment they jump, all of that stored energy starts converting into kinetic energy, the energy of motion. So the higher you lift something, the more energy you're storing in it. And pretty similar to that is elastic potential energy. This is the energy you store when you stretch or squeeze something, like a spring or a rubber band. You can literally feel that stored energy, right? That tension. That's it, just waiting to be released. Now this one is a biggie. Chemical energy is the energy that's locked away in the bonds between atoms. It's in the food we eat, like this burger, it's in the batteries that power our phones, and it's in the fuel that runs our cars. And when you break those chemical bonds, that stored energy gets released.
And finally, for our list, we have thermal energy, which, we just call heat. This energy comes from the tiny little movements of all the atoms and molecules inside of something. So the hotter an object is, like this candle flame, the faster its molecules are jiggling around and the more thermal energy it has.
Okay, we've defined energy, we know how to measure it, and now we've got a whole catalog of the main ways it's stored. You know what that means? We have all the tools we need. Let's go back to that puzzle from the beginning.
Let's look at this bus again, but this time let's use our new energy spotting superpowers. What do you see now? Can you start naming the different kinds of energy at play here? I bet you can. Let's break it down piece by piece. As you can see, this one, simple little scene, is actually jam-packed with different types of energy.
And here we go, 7 different energy stores, all in one picture. You've got chemical energy in the fuel, right? That gets turned into kinetic energy as the bus actually moves. As it climbs the hill, it's gaining gravitational potential energy. Of course, the engine is producing thermal energy, that's heat, and it's making sound energy. The headlights are using electrical energy, and get this, even the tires have elastic potential energy as they get squeezed against the road. Isn't that amazing?
So the biggest takeaway here is that energy is never just sitting still. It's in a constant state of transformation. The chemical energy from the food you eat becomes the kinetic energy that lets you walk, which creates the thermal energy that keeps you warm. It really makes you think, doesn't it? The energy you're using right now, just to watch this and learn, where are you going to transfer it next?